Okay, we're going to take these 5 questions from the homework, and hopefully this will give you a basic understanding of exponential equations. Question number 1, 3 to the negative 3x power equals 3 to the 5th power. The left side is equal to the right side. Our bases are the same, so it must be the exponents that we have to figure out. So I'm going to take the exponents. I'm not canceling out the base of 3 and 3. I'm just taking the exponents because those are the parts that we must make equal and solve for. So negative 3x equals 5. Divide by negative 3 like normal. That must mean our x is equal to negative 5 over 3. And if you plug that in into our original equations, then the exponents will be equal and both sides will be equal as well. So that is how you solve when your bases are equal. Number 6, when the bases aren't equal, well, what do? They're not equal to each other. There's not much we can do, but in this case you can take a look at 81, 27, and 9, and they are all forms of 3. 81 is 3, whoops, oh, okay. 3 to the 4th power is 81, 3 to the 3rd power is 27, and 3 squared is 9. So we transform all of them, and now all the bases are the same. And then we have an exponent on an exponent, like negative 2p over 4. You multiply them. So the bases are all 3. Combine the powers, or the exponents, to get negative 8p, 6p, and 2p. On the left-hand side, we have those two bases that are the same, so let's combine them. So the negative 8p plus 6p becomes negative 2p. On the right-hand side, it's still 3 to the 2p power. So we take those exponents, because our bases are the same, take the exponents and set them up so we can solve for p. That negative 2p, we add it to both sides. So left-hand side is 0, right-hand side is 4p. And then we divide out the 4s. Is that too fast? Maybe I'll go back. So let me do this. There is our 2p, negative 2p equals 2p. I'm going to add the 2p to both sides. 0's on the left-hand side, 4p's on the right-hand side. Going to divide out the 4, bam, bam. So 0 divided by 4, when 0 is in the numerator, we get 0. Right-hand side, we just have p, and p is equal to 0. Okay, next question, number 10. Is, whoops, when we have just one big expression, no equal sign, no solving, just combining to make it, just to simplify this, I'm going to start underlining the pieces that are common or same bases, like the 2 and the 4 we can combine, the x's we can combine, the y's we combine, and the z's we combine. But the orange lines underneath to show me and you which ones are going to be combined together. You don't have to do this, but I moved everything because it's multiplication. You can put them wherever. I put them next to who I'm going to combine them with. So 2 times 4, put the x's together, the y's together, and the z's together. And the next line, 2 times 4 is 8. Negative 4 plus 4 for the x's is 0. 2 plus 4 on the y's are 6, and on the z's, negative 4 plus a 1. It's not there, but it's really a 1, combined to be negative 3. Anything to 0 power is 1, so the x to the 0 power cancels out. And I combine everything. I got 8 times y to the 6, z to the negative 3. But like we talked about in class, you don't want negative exponents, so z to the negative 3, right there, we'll move that to the denominator, and now we have no negative exponents, and everything is clean. That's our answer for number 10. Okay, 2 more. Number 11. Another expression, no equal signs, lots of variables, exponents, and parentheses. You want to do your PEMDAS like always. You begin with parentheses, but you start with the one inside and work our way out. So I'm going to take this and clean that up. So 2x to the 3rd, y to the 3rd squared. So that means everything twice. Oh no, did I do that wrong? Oh yeah. Let me clean that up. Boom. That should be 2 to the 2nd power. Bam. Okay. And everything else stays the same. All in orange stays the same. That green and purple get expanded, or actually you multiply that by the square here. So 2 times 1 is 2, 2 times 3 is 6, 2 times 3 is 6. Now on that next line, combine all the ones that we can combine, all the same bases, just like in question 10. So 2 will go with 2 squared, x will go with x, and y will go with y. Let's combine them all. 2 to the 5th, which actually is, which is actually 2 to the 4th. So that's actually 2 to the 3rd thing. All of that to the 4th power. This 4 here goes down here. So we combined all that in the orange parentheses to just 2 bases of 2, x and y. And now we have everything to the 4th power. So that means we have to multiply everything by 4. So this 2 to the 20th is actually 2 to the 12th. We have x to the 16th and y to the 32nd power. And that's your final answer for number 11. Okay, last one is, now we have it in a fraction form. So let's see what we do first. Let's combine the numerator. All the u's together, all the v's together. In the denominator, let's multiply out the exponent. So it's 2 to the 4th, u to the 12th, v to the 8th. So hopefully you can see what happened in each case. This becoming this, and this becoming this. Next line, I spread it out a little bit, so maybe it's easier for you to see what happens here. I put the u's on top of the u and the v on top of the v, and everything cancels. Well, the v's here, exactly the same, so they cancel out to be 1. The u, there's 4 of them up here, 12 of them up here, so 4 will cancel out and you're left with 8 down here. That's where this 8 comes from. 2 to the 4th is 16. When these cancel out, there's a 1 on top, and everything stays where it is because there are no negative exponents. Bam. All right, signing out.